Good afternoon, students. Today we will be discussing about the buffers. So I am Shikha Banerjee, Associate Professor at the Bangalore University. This chapter is included in the Inorganic Chemistry of the B.Pharm first year, Unit 1. So Unit 2 in the chapter number 2. So this buffer chapter is not only for the pharmacy, this also includes the different sectors of the another chemistry, biotechnology, and everywhere the buffers are applied. So first of all, we should know what is buffer. So we know acid and base very well. So we know the substance which having the pH lower than the 7 is known as the acid, and the pH having lower than upper than the 7, that is known as the buffer. Sorry, the base. So that means the buffer and acid, there is a very much correlation. So first of all, we should know what is buffer. So a solution which resists in the change of pH is called the buffer solution. That means buffers are the compounds or mixtures whose presence in the solution resists the change in the pH even when small amount of acid or base is added to it. That means buffer is a solution which is a mixture of compound that will resist the change of pH. Suppose we want to check the solubility or the to make the assay, we have to add the acid or base. But the compound having particularly pH. But if the pH is changed with the addition of the acid or base, then it will be tough to determine the compound's purity or acid. So that's why the substance is have to be added which has minimum effect on the changes of pH. So there are types of buffer solution are two types: single solution or solution of single substance and solution of mixture. So solution of single substance is the solution of the salt of a weak acid and a weak base. So that is known as the solution of single base. That is only one salt is prepared. So ammonium acetate. So this ammonium acetate is prepared from the acetic acid and ammonium hydroxide. So weak acid here, acetic acid and the ammonium hydroxide, both are weak. Weak acid and weak base. So as a result, they are producing ammonium acid is a single salt. So that acts as a single solution buffer. Next, solution of mixture. They are of two types. One is acidic buffer, one is basic buffer. See the magic here. Acidic buffer means if the solution of a mixture of a weak acid and salt of this weak acid along with a strong base. That means the like acetic acid and the acid is combining with a base, that is the sodium acetate. So that means solution of mixture of a weak acid and salt of this weak acid with a strong base. That means acetic acid will be added as well as a strong base is used to make the salt. So that means strong base was sodium hydroxide, which was reacted with acetic acid and the salt was formed, that is the sodium acetate. So these two things are prepared to produce a acidic buffer. Hence we can go to the other combination like the formic acid and sodium formate. So these are the acidic buffer composition. Now basic buffer, whereas if the solution of a mixture of a weak base and salt of this weak base with a strong acid. So that means weak base ammonium hydroxide is there and the salt of ammonium hydroxide with a strong acid like HCl, NH4 is NH4Cl. So they can make a mix, they can prepare a basic buffer. Why the basic? Because the OH group will be playing the important role for the basicity. Now ammonium hydroxide and ammonium nitrate, that is also prepared from the HNO3, this is strong acids, but the basicity will produce due to the ammonium hydroxide. Okay. So these are the two types and which are very important for different purposes. Now going to the buffer action. The property of the buffer solution is to resist in pH of any solution in which they are added is called a buffer action. So how the buffer action will be produced. So whenever the solution is added with the buffer solution, the property which is changing the pH or a small amount of pH is changed or it will resist the change of pH is known as a buffer action. That means how the action is provided. Now buffer action or acidic buffer. So let us consider how the action is provided. Let us consider the buffer action of acidic buffer containing acetic acid and sodium acetate. Acetic acid dissociates in small extent, whereas Sodium acetate is completely dissociated in a solution as well. Like see, CH3COOH, water, CH3COO minus and H2O plus. So that means acetic acid dissociated in its forest. But the sodium acid, CH3COON, so that is dissociating completely, CH3COO Na plus Na, CH3COO minus and Na plus. So both the common ion effect like the CH3COO minus is further suppressed. That means this common ion will suppress the ionization of this sodium. So thus in this solution there are excess of acetate ion CH3COO minus and small amount of hydrogen. So that means that CH3COO minus will be more in number. So their effect is shown. So this way the effect is shown as the buffer action. See, that is a very beautiful example and pictorial demonstration. You can see this is a normal solution that is containing pH 7. So if we are adding HCl of 10 ml, we can see the pH is drastically reduced to pH 1. So that means normal solution, if the solution is added normal acid, the pH will be added suddenly. If NaOH is added 10 ml, then we can see the pH will be raised at 12, up to 12. So there is the excessive amount of pH increase. But if the solution is a buffer like this, so they have a pH of 7. But if the solution is a buffer solution, if we adding HCl, then the pH will be slightly changed. See, 6.8. That means as the solution contains buffer, it will reduce the change of pH. And NaOH is added. So if their pH will be increased a little bit above 7.2. That is, the buffer is changing the buffer is resisting the change of pH. So it's a very beautiful example. You can describe it also in your book. So when few drop of acetic acid are added to above mixture, the H3O plus ions given by the acid combine with CH3COO minus ion to form weakly ionized molecule of CH3COOH. See, whenever any small amount of acid is added, they will be added to that acetic acid. Okay? So then a few drop of bases are added to the OH ion given by the acid combining with H3O plus ion already present to form ionized molecule of H2O. Okay? So these H3O ions are consumed by the equilibrium and shift towards the right side. So as a result, the H3O plus and acidic ion is added with the acetic acid. So there will be no presence of acid. So the more CH3COO is dissociated to make up the loss of H3O plus ions. Hence, the H3O plus ion concentration or the pH of the solution is not same because there will be no obvious presence of CH3COO minus or the H3O plus ion would not be producing the acidicity. Okay? So by this way, buffer actions are produced. Next, again the example is given here. Next, practically, if we are giving an example, if 1 ml of 0.1 ml solution HCl is added to the 100 ml of pure water, the pH is reduced from 7 to 3. If the strong acid is added to the 0.0 or 0.01 molar sodium containing equal quantity of acetic acid and sodium acetate, that means that is containing a buffer, the change will be changed to 0.9 units only. That means small amount of change. Again, we are seeing a pictorial demonstration which is very beautiful, easy. So this is unbuffered water and this is a buffered containing water. And the pH is 7 near about. So if we are adding 1 ml of 0.1 normal HCl, the pH becomes much lower and it becomes acidic. But the buffer having the changes of pH which stable. Suppose again unbuffered water and buffered 7.0 solution, we are adding 1 ml of 0.1 which the pH will be higher. That means the compound will be basic, but the buffer which will having no changes. Okay. So coming to the pH of the buffer solution and changing the pH, and how can you calculate the pH of any solution can be calculated through the buffer equation. So the expression of this buffer equation is the effect of ionization of the salt of the weak acid and the common ions. Then we have to go for the calculation of the buffer by the Henderson-Hasselbalch equation. So this equation is very, very important for you. Like this, I am discussing again it. If the weak acid is like HA and the salt is BA, then they will be dissociated like this. HA plus H2O, that means acid, is dissociated into salt to H3O plus and A plus. So the dissociation constant Ka is calculated as into the concentration of the acidic ion and the basic ion divided by the unionized molecule of acid. Okay. Next, again we are going to the logarithm of this formula. So the equation is mathematical rearrangement of the acid dissociation constant equation like this way. So the dissociation constant like the H plus A minus, if it is used, then we can calculate the H plus and A minus, that is the acid, and the HA is the unconjugated acid. So if we make rearrangement of this substance, so see if you can multiply K into HA and only H plus as concentration you want to know, then the basic concentration is divided. So see Ka into Ha and divided by A, and this is the constant of H plus ion. So the taking the logarithm of the both of the equation, log H plus and log Ka into H divided by A minus A. So if it is calculated and the log will be whenever opened, the log will be is reacted or calculated with the Ka plus log Ha by A minus. Okay. So here the negative sign is present. So if we multiply both with the minus 1, because we have to calculate the minus logarithm hydrogen ion concentration, and pK, like this formula is known as pK, like minus log pK. Why minus? Because whenever pH equals to log K equals to pK is in minus Kb plus minus Ha by Ha minus is used. That means minus is given to calculate the pKs. Now, pK means if the equation is reversed, Ha divided by A minus. So where opening of the bracket, the minus and minus will be plus, and the formula will be pH equals to pK plus log A minus and by HA. That is the pK, that is the dissociation constant of the acid, and log A means the concentration of the base and the concentration of the unionized acid. That's why HA is written. By the same way, we can calculate the Henderson-Hasselbalch of a base BH plus H plus BA minus. So K will be H plus into B divided by BH. So if we are taking the pK of the solution reaction minus log 10 H plus B minus B and BH. So minus log 10, we have to calculate the log H. So that's why it has been divided P log H minus log 10, because it is minus is outside the bracket, so it will be multiplied with that equation b minus a and bh plus. So whereas log minus a मतलब क्या होता है? Log minus a. So log a, that is the pH of the base, equals to pH equals to pKa अथवा pKb log by Tn by h. Okay. So by this way we can calculate the basicity of the acid and the bases. Now there are some factors affecting the pH of the buffer of the solution like this: temperature. If the temperature is increased, there is the pH of the buffer is also increased. For example, an increase in the pH was found in the case of acidic buffer, whereas in case of boric acid sodium borate buffer, pH was found to be decreased with the temperature. So it depends on the matter to matter. So addition of a neutral source to the buffer causes changes in the ionic strength and thereby changes in the pH. So the buffer causes changes in the ionic strength and thereby changes in the pH. Okay? So dilution buffer with water. So it causes obviously dilution with water because buffer with water is reduced a huge amount of pH. Addition of neutral salt. So if the neutral salt is added, the buffer causes changes in the ionic strength and there will changes in the pH also. Dilation buffer with water causes an elevation in the activity coefficient, uh, causes a small negative or positive deviation into the buffer. Combined relation between the buffer and capacity. So the buffer action, buffer capacity is equivalent to each other. So there is some selection criteria for the buffer, it will be again discussed in our class. I think this class has been lengthy for a long time, so that's why we will be using buffer action, importance of buffer solution. They have to take. Okay. So roll-up buffer means that the buffers are also used for different ophthalmic solution, pharmaceutical formulation, pharmaceutical assay, pharmaceutical drugs, pH measurement, maintaining stability for certain oxygen compounds, certain dyes, certain pesticides everywhere. It is essential to control the pH of solution, which finding our solution. So that's why we brought this solution into the market. They can also address it to it. Buffer standard buffer system. They are designed to provide a solution having a pH of strong. So we have this solution having causes a actual pharmaceutical buffer also. They are designed maintaining pH limits in pharmaceutical preparation also. So preparation buffer is prepared is dependent upon the IP. Follow the methods and stability is also required because many compounds are there which are unstable with the moisture and environmental effects. So they have to be calculated with precaution. Whenever they are opened, they should be labeled and their expiry should be labeled so that people will understand this compound is degraded or not. So next, how a buffer works. This is a visual demonstration. So you have to study how the buffer works and what are the buffer solution measurement, बफर को कैसे बनाया दिया जाता है और एक बात में छोड़ गई स्टेबिलिटी ऑफ बार्स वो कैसे होगा सो बफर को सोल्यूशन में रखो दूसरों को तुम्हारी बफर में हाथ डालने के लिए मत दो एंड स्टेबिलिटी विल बी like 3 to 6 months but you can check the stability in the humidity chamber also. So very careful about the power selection. Now I am ending the topic here. Okay. There are some tonicity related problem that we discuss in the later classes.